The Compendious Book on Calculation by Completion and Balancing is an Arabic treatise on mathematics written by Muḥammad ibn Mūsā al-Khwārizmī, around AD 820 while he was in the Abbasid capital of Baghdad. Translated into Latin by Robert A. Chester in the mid-12th century, it introduced the term algebra to European languages including English. The Compendious Book provided an exhaustive account of solving for the positive roots of polynomial equations up to the second degree. Several authors have also published texts under this name, including Abu Hanifa al-Dinawari, Abu Kamil Shuja ibn Aslam, Abu Muhammad al-Adli, Abu Yusuf al-Misuzi, Abd al-Hamid ibn Turk, Sind ibn Ali, Sal ibn Bisr, and Sarafadin al-Usi. Legacy. R. Rashid and Angela Armstrong Wright. Al-Khwārizmī's text can be seen to be distinct not only from the Babylonian tablets, but also from the Diaphantissa Arithmetica. It no longer concerns a series of problems to be resolved, but an exposition which starts with primitive terms in which the combinations must give all possible prototypes for equations, which henceforward explicitly constitute the true object of study. On the other hand, the idea of an equation for its own sake appears from the beginning and one could say, in a generic manner, insofar as it does not simply emerge in the course of solving a problem, but is specifically called on to define an infinite class of problems. J. O'Connor and D. F. Robertson wrote in the MacTutor History of Mathematics archive, perhaps one of the most significant advances made by Arabic mathematics began at this time with the work of Al-Khwārizmī, namely the beginnings of algebra. It is important to understand just how significant this new idea was. It was a revolutionary move away from the Greek concept of mathematics, which was essentially geometry. Algebra was a unifying theory which allowed rational numbers, irrational numbers, geometrical magnitudes, etc., to all be treated as algebraic objects. It gave mathematics a whole new development path, so much broader in concept than that which had existed before, and provided a vehicle for future development of the subject. Another important aspect of the introduction of algebraic ideas was that it allowed mathematics to be applied to itself in a way which had not happened before. The book was a compilation and extension of known rules for solving quadratic equations and for some other problems, and considered to be the foundation of algebra, establishing it as an independent discipline. The word algebra is derived from the name of one of the basic operations with equations described in this book, following its Latin translation by Robert A. Chester. Since the book does not give any citations to previous authors, it is not clearly known what earlier works were used by Al-Khwārizmī, and modern mathematical historians put forth opinions based on the textual analysis of the book and the overall body of knowledge of the contemporary Muslim world. Most certain are connections with Indian mathematics, as he had written a book entitled The Book of Bringing Together and Separating According to the Hindu Calculation, discussing the Hindu-Arabic numeral system. Quadratic equations. The book classifies quadratic equations to one of the 6 basic types and provides algebraic and geometric methods to solve the basic ones. Historian Carl Boyer notes the following regarding the lack of modern abstract notations in the book. The algebra of Al-Khwārizmī is thoroughly rhetorical, with none of the syncopation found in the Greek Arithmetica or in Brahmagupta's work. Even the numbers were written out in words rather than symbols. Carl B. Boyer, A History of Mathematics. Thus, the equations are verbally described in terms of squares, roots, and numbers. The 6 types, with modern notations, are squares equal roots, squares equal number, roots equal number, squares and roots equal number, squares and number equal roots, roots and number equal squares. Islamic mathematicians, unlike the Hindus, did not deal with negative numbers at all, hence an equation like bx plus c equals 0 does not appear in the classification. because it has no positive solutions if all the coefficients are positive. Similarly, equation types 4, 5 and 6, which look equivalent to the modern I, were distinguished because the coefficients must all be positive. The Algebra operation is moving a deficient quantity from one side of the equation to the other side. In an al-Khwārizmī's example, x2 equals 40x minus 4 by 2 is transformed by Algebra into 5 by 2 equals 40x. Repeated application of this rule eliminates negative quantities from calculations. Al-mucabola means subtraction of the same positive quantity from both sides. x2 plus 5 equals 40x plus 4 by 2 is turned into 5 equals 40x plus 3 by 2. Repeated application of this rule makes quantities of each type appear in the equation at most once, which helps to see that there are only 6 basic solvable types of the problem, when restricted to positive coefficients and solutions. Subsequent parts of the book do not rely on solving quadratic equations. Area and volume. The second chapter of the book catalogues methods of finding area and volume. These include approximations of pi, given 3 ways, as 3 1/7, square root 10, and 62,832 20,000ths. This latter approximation, equaling 3.1416, earlier appeared in the Indian Aryabhatiya. Other topics. Al-Khwārizmī explicates the Jewish calendar and the 19-year cycle described by the convergence of lunar months and solar years. The last part deals with computations involved in Islamic rules of inheritance.